I am Rajesh, HOD, Department of Mathematics from E-Content Development Center, Majlis Arts and Science College, Paramannur. Today, I am going to take a theorem. Its statement is, every convergent sequence is bounded. Every convergent sequence is bounded. After studying this topic, you will understand the concept convergence of a real sequence, bounded of a real sequence. Also, you will understand the relation between convergence and bounded, convergent and bounded of a real sequence. First, we have to discuss about the concept convergence of a real sequence. A sequence x equals xn in R is said to converge to x belongs to R for x is said to be a limit of sequence xn. For every epsilon greater than 0, there exists a natural number k of epsilon such that modulus xn minus x is less than epsilon for all n greater than or equals k of epsilon. This is the definition of convergence of a real sequence xn. That means for every epsilon greater than 0, there exists a natural number. There exists a stage in set of all natural numbers we denote it by k of epsilon such that the distance between xn and x, that means modulus xn minus x, is less than epsilon for all n greater than or equals k of epsilon. For example, limit of the sequence 1 by n equals 0. In this example, we use corollary of the Archimedean property. The statement is, if t is any positive real number, then there exists a natural number nt such that 0 less than 1 by nt less than t. That means its reciprocal lies between 0 and t. Okay, here epsilon is an arbitrary positive real number. Then by this corollary, we can find a positive real number k such that 1 by k less than epsilon. 1 by k less than epsilon. Next, if n greater than or equals k, then taking reciprocal on both sides of this inequality, we have 1 by n less than or equals 1 by k. Already we have 1 by k is less than epsilon. Clear? Consequently, if n greater than or equals k, we can write modulus 1 by n minus 0 equals 1 by n. Modulus 1 by n minus 0 equals 1 by n. 1 by n is also less than epsilon. That means we get the distance between 1 by n and 0 is less than epsilon for all n greater than or equals k. So, by the definition of convergence of a real sequence, we can say that limit sequence 1 by n equals 0. Clear? Next, we have to discuss about the concept bounded of a real sequence. A sequence x equals sequence xn is said to be bounded. Then there exists a positive real number m such that modulus xn is less than or equals m for all n belongs to capital N. That is the definition of bounded of a real sequence. A real sequence is said to be bounded, then we can see a positive real number capital M such that modulus xn is less than or equals capital M for all n belongs to capital N. For example, sequence 1 by n is bounded because every element in this sequence lies between minus 1 and plus 1. Here we can take capital M equals 1. Another example, sequence minus 1 raised to n. This sequence is bounded because the first term of this sequence is minus 1, second term of this sequence is plus 1, third term of this sequence is minus 1, etc. That means every element in this sequence lies between minus 1 and plus 1. Clear? These are the examples of bounded sequence. Next, we will discuss the theorem. The statement is, a convergent sequence of real numbers is bounded. Convergent sequence of real numbers is bounded. Proof. Here, we assume sequence xn is a convergent sequence. So, by the definition, it has a limit. We denote it by small x. That means we have limit sequence xn equals small x. Then by the definition, we can write for every epsilon greater than 0, there exists a natural number k of epsilon in n, capital N, such that modulus xn minus x less than epsilon for all n greater than or equals k of epsilon. Here we choose epsilon equals 1. So this definition becomes modulus xn minus x less than 1 for all n greater than or equals k of 1. Clear? Next, modulus xn. Here we add and subtract x. Then this becomes modulus xn equals modulus xn minus x plus x. Next we apply the triangle inequality. The statement of triangle inequality is modulus a plus b is less than or equals modulus a plus modulus b for all A comma B belong to R. A comma B are two real numbers. That means the modulus of first term plus second term is less than or equals modulus first term plus modulus second term. Here we take xn minus x as a first term and x is the second term. So we apply the triangle inequality. So this becomes modulus xn minus x plus x is less than or equals modulus xn minus x plus modulus x. Clear? Modulus xn minus x plus modulus x. But we have modulus xn minus x is less than 1 for all n greater than or equals k of 1. Clear? So this becomes this strictly less than 1 plus modulus x. 1 plus modulus x for all n greater than or equals k of epsilon. But the definition of bounded of a real sequence, modulus xn is less than or is equal to a constant for all n belongs to capital M. But here we get modulus xn is less than a constant for all n greater than or equals k. So we cannot say that modulus x1 is less than a constant, modulus x2 is less than constant, etc. Modulus xk is less than modulus xk minus 1 is less than constant, etc. Next we set capital M equal supremum, set modulus x1 comma modulus x2 comma etc. modulus xk minus 1 comma 1 plus modulus x. After setting this, we can say that every element in this collection is less than or equals capital M. That means modulus x1 is less than or equals capital M, modulus x2 is less than or equals capital M, etc. Modulus xk minus 1 is less than or equals capital M. What about modulus xk? Here we put n equals k in this inequality. So this becomes modulus xk is less than 1 plus modulus x. But we have 1 plus modulus x is also less than capital M. So connecting first and last, we can say that modulus xk is less than 1 capital M. Next we put n equals k plus 1. Then this becomes modulus xk plus 1 is less than 1 plus modulus x. But we have 1 plus modulus x is less than or equals capital M. So we can say that modulus xk plus 1 less than capital M. That means modulus xn is less than or equals capital M for all n belongs to capital N. We get modulus xn is less than or equals capital M for all n belongs to capital N. That means we can say that our sequence is bounded. That means every convergent sequence is bounded. Clear? Next, the converse of this theorem need not be true. That means every bounded sequence need not be a convergent. For example, consider the sequence minus 1 whole raised to n. The first term is minus 1, second term 1, third term is minus 1, etc. This sequence is bounded because every element in this sequence lies between plus and minus 1 and plus 1. But this sequence is not convergent. So the converse of this theorem need not be true. So I have discussed the concept of convergence bounded of a real sequence. Also, I have discussed the relation between convergence and bounded of a real sequence. Thank you.